Good day everyone, we are BSEE4A from the group of Power Rangers. I am Heart M. Salognon together with my groupmates Jana Mayer Gaza and Reina Micaela Ponteras. This time, we are going to report and present to you about the continuous fluid flow measurement.
It's morphin' time! Dino Fury Key!
So this time, my task is to present to you the ultrasonic flowmeters and inertia-based flowmeter. So first, what is a flowmeter? A flowmeter measure the rate of fluid movement through a pipe or channel. Meaning, ang flowmeter nagahambal sa aton kung ano ang kadasigon ang pagflow sa tubig or any fluid within the pipes. So some modern types of flowmeter is ultrasonic flowmeters and inertia-based or ang true mass flowmeters. So first, what is ultrasonic flowmeters? So, magambal ta guys, ultrasonic flowmeters, meaning, naga-test na sa ang kadasigon sang tubig through ng ultrasonic, meaning ginagaan niya na da sound, tapos dira ma-detect ya. So, hibaluon taon pa nun sa work through the two types of this flowmeter. One is the Doppler type, and next is the transit time type. So, una di is ang Doppler type. So, paano naman niya gagana ang Doppler type? Ang Doppler type nagagana uses the Doppler effect. Magambal ka Doppler effect ng minsan ka sa isang ambulance nga nag-aagi sa imong tubangan, di ba? Samtang nagapalapit ang ambulance, nagadasig ang iyang frequency or nagadasig ya tunog. Pero samtang nagapalayo sa gay pium, di ba? Tagaman na sa. Tapos ga-work na sa pag-change ang frequency, meaning may ginaset lang na sila nga original frequency dira nga pipe. Tapos samtang may nagaagi nga mga particles ga-change na iya frequency, meaning kung dasig or damo ang pag-change ang frequency, meaning mas dasig ang flow sang fluid or any fluid ang ga-flow. Tapos kung mas jutay naman ang pag-change ang frequency, meaning hinay lang ang flow. Amo na sa mag-test ka. Tapos pwede lang ni sa mga wastewater, slurries kag dirty fluid kay tungod if ng clean fluids ang maglabay, meaning wala may nga particles nga maglabay hindi ma-interrupt ang frequency. So amo na sa ang Doppler type. Next is ang transit time type. So ano naman ni saya? Measure time difference between sound traveling with against the flow. Best for clean fluid with no solid impurities. So para naman ni sa mga tinlo guys nga fluid. So ga work naman ni saya, example, amo ni sa ang first nga ang transducer A, amo ni sa transducer B. So both na sila, gatag na sila frequency. Tapos kung maghatag na di sa sound, i-detect na din ni receiver, siya ni si transmitter, i-detect niya na di kung ano kalawig bala ang sound nga makakadto di. Amo na sa time difference. Tapos kung ang ari naman din nga nga frequency ang maghatag kag kung dugay-dugay ya di mabatian, amo na sa ang time difference man nila nga duha. So amo na sa ang transit time kagamit time difference. Kung ano di kadasig makalabot ang signal, kag ano man di makadasig balik ang signal. So amo na sa. So meaning kung dasig di makalabot ang signal, meaning dasig ang tubig. Kung hinay naman ang galabay. Amin ang mga fluids or ini pwede man water. Next, amo na sa ang transit time guys Next is ang inertia-based or Coriolis flowmeter. Nang ano naman niya magambal kasi ni. Measure mass, flow rate directly, not velocity or volume ka. Measure siya directly sang mass, hindi ako niya sang velocity or ang volume. Operate on Coriolis force. So ano magambal ka? Coriolis force. Amo na sa guys, example, magwashing ka mo bala sang inyong mga motor. Example, may wala singan, di ba? Maguyat ka muna sang tubo kung dasig-dasig na di ba ang pressure sa tubig, amo na sa kay tungod dasig ang flow sa tubig duga tiyog-tiyog sa bla. Tapos example naman gawiyat ka mo duha ka tubo kung wala pa ga flow ang tubig, kalma pa na sa, pero kung mag-flow na sa di ba ano sa gama mo na sa ang Coriolis force. A pseudo force due to motion and vibrating tube. Magambal ka naman yung pseudo force daw ka imaginary force lang sa para sa bala kung gasakay ka sa salakyan kagulpi naglakat, di ba dumigatulog sa imo may nagatulod sa imo pabalik pero wala ginayamo na sa pseudo force. So high accuracy and reliability in chemical industrial application. So paano naman sa work ng Coriolis principle of operation? Ang yang pag-operate, di ba? Makita niyo to gina sa picture mo sa ang tube to naga-vibrate na sa kag naga-resist ang fluid sa motion. Amo na nga mo na sa blang tubo pirmi ang mga hose kaga creates Coriolis twisting na mo na sang tawag gali kung amo na ang mga host nyo tawag na Coriolis twisting. Amo na sa. So, meaning, degree of twist is approximately equal sa mass flow rate. Meaning, kung damo kuno ang twist-twist na da, meaning dasig ang flow rate. So, may equation na guys, which is ang force equals to negative 2 ng angular velocity times mass. So, may example problem na da guys, kung paano nyo na sa i-apply nga formula. So, mga na-intindihan nyo lang. Kaya pas lang na. So, design and operation. Common designs use U-shaped tubes that vibrate. So, nga U-tube gid ang ginagamit. So, kaya ang U-tube mo sa pinaka-effective nga form sang pipe para ma-detect ya ang vibration kay twisting nga ginadala ni Coriolis effect. So, the more fluid mass passes through, the greater the twist, and sensor measure this twist to determine mass flow rate. Sa. So, engineering improvements to reduce vibration errors to identical U-tube are used. So, gamitan nila duwan na ka U-tube para if mag-vibrate in opposite direction, ma-cancel out lang na ang mga external vibration. Example, mga vibration na sa mga motor, naman sa external vibration. So, magnetic coils, naman sa mga built-in nga mga, kumbaga do ka add nga power sa iyang flow meter. Si magnetic coil, si temperature sensor, kag si density measurement. So, ang iya outputs, ang Coriolis flow meters, maka-measure sa 3 variables, hindi lang isa. Una is ang si mass flow rate, si density, kag si temperature. Using this, the meter can also calculate volumetric flow, which is ang formula. Volumetric flow is equals to density times mass flow.
Good day, everyone. I am Jana Miragasa, and I will be discussing 3 topics, which are thermal base flow meter, positive displacement flow meter, and a wave feeder. So let's start with the thermal base flow meter. What do we mean by a thermal base flow meter? So this type of flow meter works using the wind chill effect. So what do we mean by wind chill effect? So maghama ka wind chill effect, it is similar sa how you feel colder whenever ang hangin ka blow sa imong skin, because the moving air carries away heat sa imong skin. For example, imagine you ara ka sa tubangan sang fan tanay. Then you put your fan in front of it. This time naka-off pa ang fan, wala pa naka-turn on. So wala air nga may kabatyagan imo hand. So normal na ang temperature. Now, we turn on the fan. Syempre, moving air heats your hand and takes away the heat. That's why you feel cooler. Let's say, yung pataasan mo ang temperature, ang speed sang fan. Syempre, damo, di ba mas kusog ang rotation, mas ang air mas kusog pagid. The air nga gina-remove siya even more nga heat sa imong hand. That's why you feel colder. Amo na siya ang concept ka thermal base flow meter. Inside the flow meter, there is a heated sensor like sang aton nga warm nga kamot. When gas flow past it, it cools the sensors down. Just like ang air, amo na siya ang gas nga na-compare naton from the fan. The faster the gas flow, the more it cools the sensor. By measuring how much energy is needed to keep that sensor hot, the flow meter can tell how much gas is flowing. That's the mass flow rate. So this type is commonly used for gases like air or natural gas. For example, in HVAC system, leak detection, or engine control. It is very sensitive and measured through mass flow, but only works accurately if the gas composition stays the same and the fluid is clean. Next, we have the positive displacement flow meter. This one naman works like counting buckets of water. Imagine you're filling a swimming pool. Ipunon mo. Using a bucket lang. Wow. Each time you fill and pour one full bucket, you know exactly kung ano kadamo nga tubig ang gidugang mo. If you count how many buckets you have poured, you can find the total volume of water sa swimming pool. That's how the positive displacement works naman niya. Inside sang meter, it has small chambers or gears. Balidwan na siya ka gears that trap a fixed amount of fluid each time nga ga-rotate sila. By counting how many rotation happens, the meter can tell how much fluid has passed and how fast. This type is very accurate and linear, which make it ideal for custody transfer like measuring gas, water, ang metrohan naton, or oil and bidding and trade. It is not affected by turbulence or swirl, but since it has a moving part, it only works well with clean fluids and needs regular maintenance to prevent wear. And lastly, we have the wave feeder. which is used naman niya for solid materials like powders, grains, and cement. It uses a conveyor belt with a load cell underneath sang belt to measure ang weight sang material nagapatong sa belt, and a speed sensor to measure kung ano kadasig ang belt nagiho. By multiplying the weight by speed, then divided by the length sang belt section kung diin ng portion ang material, we can get the mass flow rate of solids, which is expressed in pounds per seconds. Now, for example, think about of a rice mill where ang rice grain, ang bugas, move on the conveyor belt. Then, if you place a weighing scale sa dalom sang belt, it can measure ano kabugat ang bugas on that section. If you also know how fast ang belt kagiho, you can figure out how much rice passes each seconds. That's how a weigh feeder works. It continuously weighs the materials on the belt using a load cell and measure the belt speed using tachometer. The product of these two gives the mass flow rate of the solid materials. This method allows continuous measurement and control of solid materials in industries like cement, mining, and agriculture. However, it needs regular calibration, and belt wear or slippage can affect accuracy.
Good morning, everyone. I'm Reina Micaela B. Penteres, and we will talk about change of quantity flow measurement, insertion flow meters, and lastly, process or instrumentability. Let's start with the first method, change of quantity. This is an indirect way of measuring flow. This principle is simple. We use a level sensor to see how much fluid is in a tank at the start of a period and again at the end. The change in volume divided by the time it took for the change give us the average flow rate. It's a straightforward application of this formula. Now, let's break down the advantages and limitations. On the pro side, the biggest advantage is that there's nothing inside the pipe to clog, corrode, or cause a pressure drop. You can often use existing equipment like level sensors already on a tank, and it's inherently safe for harsh fluids. While on the con side, the major limitation is that it's not a real-time measurement. You get an average flow over a period of time, not an instantaneous reading. Its accuracy is entirely dependent on how well you can measure the tank level, and because of the time lag, it's not suitable for fast-acting control loops. Now, let's move to our second method, insertion flow meters. If change of quantity works from the outside, this method works from the inside, but only at single point. The concept here is that a probe is inserted into the pipe through a single tap. This probe measures the fluid velocity right at tip. At its tip, since we can't measure the velocity everywhere at once, we use our knowledge of fluid dynamics to infer the total flow rate based on its single point measurement. There are several types like insertion, turbine, vortex, magnetic, and ultrasonic, each with their own sensing principle. Now, let's talk about the advantages of insertion of flow meter. First, significant cost saving, especially on large lines. Second, the ability to be installed without shutting down the process. Third, they create only minimal pressure drop in the pipe. And lastly, they're versatile across many fluid types. However, the limitations are important. Their accuracy is highly dependent on a stable, predictable flow profile. If the flow is turbulent or asymmetric, the guesswork gets worse. Then, the probe is exposed and can be damaged by high velocity or particular matter. And also, they typically require calibration to the specific pipe and flow conditions. Lastly, they are generally less accurate than full bore meter. This brings us to the most critical part. How do you choose? You need to ask, what is the fluid? Is it liquid, gas, slurry? Is it clean or dirty? Is it corrosive? What are the pipe and flow conditions? What's the diameter? Is the flow steady? What are my performance requirements? How accurate do I need to be? Do I need real-time control? What is the installation environment like? Is it hot? Is it accessible? Answering these questions is first and most important step.